Okay, now I'm going to go over how to use Excel to do all those calculations for accumulated degree days. So all those tables and stuff that I've been showing you in the presentations, I use Excel. And the reason that I use Excel is because you can code in different formula, make it really, really easy to sort things. Everything just makes it really easy. So this is how we do it. Here I've got an open Excel sheet. Now, I know some people haven't used Excel very much, so I'm going to go over the basic things that I use on a regular basis. If you need to know a little bit more about, how to use maybe or do a little more in-depth stuff, go on YouTube. There are a lot of step-by-step things on YouTube. So I'm just going to focus on those things that you will need in order to do your assignments and do time of colonization estimation. So remember what you need in order to figure out time of colonization estimation. Always go back to your basic question. You're going to have a body. You have maggots from that body. So first, you need to know what that species is. Second, you need to know what the development data for that species is. And third, you need develop the amount of temperature that has happened over the time when the body was probably out there. Okay, so three major things. Now, let's start with the species. Let's say that you found you got called in, you found a body, and it had, Chrysomya rufossis on it. Pretty straightforward, right? So you will have a development table that looks like this with some different species. I will give this to you. This is in your module. It should be up on the website, on the campus site. So go and find that. You need this information. Remember, this is the species. This is the threshold temperature. So in this case, rufossis is 10 degrees Celsius. We reared it at 25 degrees Celsius. This is how many hours it took to go through each stage. Now, this development data, the rufossis doesn't have pre-pupal information. Fine. You don't need to worry about that then. Okay. So let's say we've got Chrysomya rufossis. So the first thing that I want to do is I want to transfer this information onto my spreadsheet. So I'm going to do that. So I'm going to put Chrysomya rufossis here. Now remember, this is just the way that I've gotten to do it so it makes sense for myself. You can set up your tables differently if you want to. Just this is what I do. So then I put the temperature here. So T for temperature. And so the rearing temperature is 25°C. Okay. Now, the egg stage in hours is, let's see, what did I say it was? It was 12 hours to go through the egg stage. First instar is 18 hours. Second instar is 34 hours. Third instar is 106 hours. There's no pre-pupa stage, but the pupae is 119 hours. Great. Okay, so remember what we do next. We now need to change this into accumulated degree hours. So step one for accumulated degree hours, we need to figure out how many degree hours is necessary for each individual stage. So I will list this as degree hours, or DH. So this is where Excel becomes really, really nice. Let me focus in on this so you can see exactly what I'm doing. So you can put in a formula in Excel. So we have our thing here. So remember our formula. It's average temperature minus the threshold times the unit of time. Let's make this. Okay. So if I put my temperature here, this, since it was reared at a standard temperature, the average temperature is going to be 25 degrees. So what I can say is I've got my average temperature, which is this. Okay, so in order to put a formula in, you first need to put the equal sign. So what this is doing is it's telling the computer this is going to be a formula. Then you just use your normal rules. You use parentheses when you want the the first calculations to go first, and then you move on from there. So I need to take my average temperature. So I put a parentheses, open parentheses, and then anything that I click now, it's going to read whatever's in that that cell. That's why I took the C away, because the C would confuse it. So I just want a number in there. So that's 25 degrees. So 25 degrees now our average temperature. Then minus our threshold temperature is 10. Minus 10. Close parentheses. So that's going to do the average temperature minus the threshold. Now I need to multiply by my unit of time. So remember, we're doing degree hours. We're trying to figure out how many degree hours are necessary in this for 12 hours. So multiply, that's a star. And then you multiply by that. Okay, so now I've got average temperature, 25, minus my 10 times that. Now, the reason that I like doing it this way is then if I make a mistake, if I put in a wrong number, then it's really, really easy to go and change just, say, a single thing. So if I hit enter, it's going to do the calculations for me. Now, let's say I thought it said 25, but they were really weird at 26. So instead of having to go through and adjust the calculations here, I can just change this. So let's say if it was at 26. Oh, look, it automatically changes it. So that makes it nice. It was at 25 though. Okay, now, once you have figured out, or once you have put in one of these formula, Excel has a neat way. See this little block down at the bottom? So the cell is highlighted, or it has this border around here. If you hover over that little block in the bottom right-hand corner, it turns into this plus sign. So click on that block, hold down your mouse button, and drag. What this is going to do is this is going to drag that same formula all the way across. Now you have to do a little bit of fixing here. So in this case, notice it says K3. If you want to see what it is referring to, you can click on this thing up here. So now it's saying 12 times that. And we don't want that. We want this to be the average temperature. So you can just grab and drag that over there. So now it's average temperature 25 minus 10 times 18. Enter. So fix this one. Average temperature minus 10 times 34. Okay, average temperature minus 10, there. Average temperature, there. So that'll do it. Now, if you want to do it a slightly different way, so again, we can figure out DH. So this way, instead of focusing on a certain cell, I can just type in the temperature. So in this case, 25, 25, average temperature minus 10, my threshold, remember those are given, times this. Boom, 180. And then again, drag, hover over that square, drag all the way across. And now we've got the degree hours, or degree day. This is degree hours. Okay, so 2 ways of doing it. I like doing it this way, that way. So now if, say, I need to change this temperature for some reason, 27, now they're all going to change. See how that worked? If maybe it's at 30, now they're all going to change. Okay, 2730. So I can change it all. If I tried to do that here, it doesn't change. I have to go into each and every one and change it. So I personally like putting a little bit more effort right at the beginning. So then if there's a typo, everything will auto change for me. But you do whatever you think is easiest. Okay, now, regardless, you then need to turn this into degree days if you are working with days. So you want to, let's delete that. So what you want to do is now, degree days, the way that you figure out days is you divide hours by 24, right? Same thing happens with degree hours and degree days. So all I need to do is I need to take this, divide it by 24, and I will get degree days. So again, you put your equal sign telling the computer that this is going to be a calculation. You equal this, and then the slash is the division sign, okay, divided by 24. 7.5 days. So I've done it once. Now I can hover over this little block and drag. Done. Now, if you want to make sure that really dividing degree hours by 24 equals degree days, you can do it like we learned in the lecture, where instead, let's say we turn these into days. So remember, you just take 12 divided by 24. Remember, you take your average divided by 24, and you've got that. So 12 is half a day, right? So then you can drag and drop. There we go. And then you can figure out your degree days from there. So that's going to equal 25 minus 10, average temperature, minus a threshold, times half a day. Okay. Drag and drop. So notice that the degree days are exactly the same either way that I calculate it. I do sometimes do these double calculations just to double check. If they come up different, that means I have put in something wrong. I've made a typo and I need to find that answer. But here we are, the same degree days, degree hours. Fantastic. Okay, so now we're in degree days. Now, we figured out how much each stage needs for to get to the next stage. Now we need to do that adding up. Remember, we have to have the range. Okay, so I will make another thing. This is a little, I will call this ranges. And so this should be end of egg stage. So I'm looking for degree days. And so this is just going to equal whatever this is, right? Boom. End of egg stage, 7.5 degree days. Now, end of first. So the end of first means it goes, the eggs are oviposited, it goes to the end of the egg stage, starts the first, goes all the way to the end of the first instar. Okay, so in this case, we just need to add that plus that. So the egg stage plus the first instar stage. Okay, end of second equal that plus that plus that. Okay, and we just keep going. Equals that plus that plus that plus that. And finally, end of pupae equals that plus that plus that plus that plus that. Enter. Okay, so now we've got our range. So let's say we found third instar larvae on a dead body. Right. We found out they were Chrysomyrmex rufosses. We figured out how many degree days. So we found third instar larvae. So then our range is going to be end of second. So end of second to the end of the third. So because we have our maggots are in the third instar, we don't know if they just came out of that second instar or they're just about going to the pupal stage. So they are somewhere between 40 and 106.25 degree hours. So I always like highlighting this just so I know what I'm doing. Okay. So now I figured out my range. This is the range that I'm looking for. So now we figured out what is necessary to have accumulated in time for these maggots to be in the third instar on that body. So our next step then is to figure out when that actually happened in time. So this is when we start that second table. So in that case, we need the temperature data. So temperature data, this is an example of some data that you can get from, say, NOAA, our official temperature site. This is something, and let's say, the body was found on the 7th. Here, so I've got some data. It's on July 7th, 2015. So this is from several years back, a case. And this is actually some data from an actual case that I worked. Okay, so 2015. And I usually go back when I pull data at least 2 or 3 weeks. So I did, all the way to the 21st, around there. And I do this based on, I know approximately how quickly maggots grow at this point. If you're new at it, it's better to have more data than less. So if you're new, and this is the first time, my first couple of cases that I worked, I got 3 months worth of data just in case. Okay, but this is what the day is going to happen. So you're going to put it in here. Remember, all you really need is the max and the min temperature, right? Because that's all that you are calculating is your average temperature. Now, this is already in Celsius, but this gives you the date. This gives you the station. What I like doing is I have a second sheet over here to add a sheet on on this Excel, you just click this plus right there so you can add a sheet. So I added a second sheet, and I always keep the raw data. This way, if there's a mistake, I make a typo, I already have the raw data to go back to. Okay, so what I'll do is, let's see, I'm going to copy this. So to copy something, you can just start at the top, click and drag. So now you copy it, and then you can either right click and copy, or you can Control C or Open Apple C, whatever you're on. And then I'm going to put it over here. So I'm going to paste it. Now, if you see these little numbers right here, these hashtags basically, that just means the column isn't quite wide enough to show the numbers. So if you hover over the right hand edge of that column and double click, it'll make the column wide enough. Okay, so now I've got my dates going in order. I'm going to go back here and I'm going to copy the max and the min temperature. So again, copy, and I'm going to paste those there. So when I paste, you'll notice that I just highlighted one cell. That's fine. If you highlight a cell, that's where the upper left-hand corner of the box that you just copied is going to start. So you can do that. Okay, so now I've got my temperature. That's the max. That's the min. Here it is. Now remember, though, I like working with the numbers switched. I like working backwards, where the very top here is my day that the body was found. I keep going backwards. Now, that's not how the data comes. So what you can do is you can highlight your data like this. So highlight everything. And then if you go up to editing, you see this AZ thing right here. So it's under editing on your what do they call this? A ribbon? I don't know. Okay, so click that. You could say sort oldest to newest, sort newest to oldest. So if you sort newest to oldest, that's going to sort by this first column. So you see how that just switched, and all these numbers came with it. Now, just to make sure that this was, I always spot check. You know, that's why I have the raw data. So let's say, so it says here on July 5th, the max was 36.1, the min was 22.2. We can go back to our raw data. Let's see, was that July 5th, 36.1, 22.2. Hey, it worked out. So you can just spot check over and over again. A reason to keep that raw data. Okay. Now, let's make this bigger so you can see what I'm doing again. Now we've got our dates. So remember, our next thing is to figure out how many degree days accumulated on each day. So degree days. Okay, so again, we got to do some calculations here. We got to do our average temperature. So let's start out with figuring out the average temperature. So to figure out the average, you do equal. And this is where Excel does some really great stuff. They already have some calculations in here, like average. So you can say equals, and you type the word average. Notice how I started typing, all these different things come up. These are all the different types of calculations you can do. So if you type out average, this will come out there. That's good. Just use the normal average. Average. So what you're doing here is saying, okay, first I put the equals. Here's a formula. Now this is what the formula is going to be. I want you to average these numbers. Then you put it in open parentheses and you click on the numbers. So I clicked on this first one and then I just dragged to the second one. I want you to average these two numbers, end parentheses, and click enter. So the average of 35.6 and 23.9 is 29.75. So if you want to double check something like that, feel free to always bring up a calculator. Do this really quickly. What is this? 35.6 plus 23.9 divided by 2. Hey, we got it. Cool. Okay, now the reason that I put in these formula, though, because this is where it gets easy. You don't have to do things by hand. Remember this whole corner thing? So what I will do is I will grab this corner, hover over, click on the bottom right-hand corner of that cell, that green outline, and drag. And what this is going to do is it's now going to copy that formula all the way down. So now it is doing the average of those two. This is doing the average of those two. So I didn't have to type this in 1,000 times. This is why I do it this way. Awesome. So now I've got an average temperature. What else do I need? I need its average temperature minus the threshold. So when we say the threshold, we are talking about the threshold temperature for the insect. And so the threshold temperature is something I will give you. The threshold temperature for Rufasis, remember that is on this thing you got here. It's 10 degrees Celsius. Cool. So average temperature minus the threshold. So I always put minus threshold. So in this case, you can just put an equal again, and you put whatever this number is minus 10. Boom. So that's going to do that. Again, click on this bottom right-hand square, drag all the way down. Calculations are done for you. Now, again, the reason why I like doing this is, okay, what happens if for some reason I mistype something or I copied something wrong? Like, uh-oh, this was actually 21.3 or 0.9. If I change this, all those calculations are automatically going to change. So I'm just basically setting it up so that if I need to change something, I can. Okay, so now I've got our threshold. So what's the next step? So it's average temperature minus the threshold times the unit of time. So this is 1 day. So we can just, multiply everything by 1. Cool. So I don't need to put that in there just because it's 1 day. But, I usually don't, but just so you can see what I'm doing. So I add it by 1 day. So in this case, I can take this average temperature. This is minus the threshold times 1. There we go. And then again, drag all the way down. So now this means this is my degree days, right? For each day. So on the 7th of July, 19.75 degree days accumulated. On the 6th, it was 20.55. Okay, so this looks very familiar, right? This is what we've seen over and over again on all those lessons. Now, I need to add them up. So remember, this is like putting it in the piggy bank. We're adding things up. So we call those the accumulated degree days. So the way to do this, I figured this out. It's a little tricky. I like doing the dragging. So if you want to have a cell that just is the same number over there, the easiest way to do it is to make sure that if any changes happen, they auto change. You put equals and then just click on that cell and hit return. So then if I change something over here, so let's say, remember this is all calculation. Let's say, this is supposed to be 36. I can change one number, all the calculations will automatically change. Okay. If I didn't do it that way, I'd have to go through and change it all by hand, and I might miss something. I try to take out as many potential error methods as possible. Okay. So did that. Now, this is where it gets a little bit different. So remember, I have to add. So this is what I put in the piggy bank on the 7th. Now I have to add what I got the day before. So I say equal what happened on the day before plus above. Enter. Now the reason I do it on this column instead of this one, I do it on this column is because now I can grab this bottom right-hand square and drag all the way down. And you see a running total. So in this case, you see how it's that number, what we got on the 5th, plus what was in our piggy bank. Good. This day, it is what we got on the 4th, plus what was in our piggy bank. So we just keep going down like that, and now we have a running total. Okay, so these are our accumulated degree days over time. Now we have to put together. So remember, we found third instar Chrysomya rufacis larvae. We've done our calculations. We know that in order to reach the third instar, the maggots have to experience a minimum of 40 degree days and a maximum of 106.25. That's our range. So now we just need to find that range on our calendar here. So just like we've done before, so I like putting the name of the species here. Okay, so just like we did before, we need to find when we first see 40. So this is the end of the second instar. Not enough on the 7th, but we got just enough on the 6th. So I put end of second there. And now we need to find the earliest date. So this is when they reached 106. So no. So you just basically go down until you reach 106. So 110 is more than 106, done. So this will be the end of the third instar. So what this is saying, and then I will highlight these just to make it really easy to see. So what this is saying is that the body had to be available for colonization sometime between July 2nd and July 6th. Because if it was available earlier, the maggots would have laid their eggs earlier on there. The maggots would have been older. We wouldn't have seen them in the third instar. They would have been pupating. Okay? Because they would have reached that 106, which is the max they could have been. If they had been laid the day before, they would have been pupae. If they had been laid, like on that day, they would have been first instar. So this is the range. And so this is what I tell my officers is the body was available for colonization between July 2nd and July 6th based on the time of colonization estimation. And that's what we do. Dun, dun, dun. So this is how you're going to do it. So walk through this many, many times and you will be able to do it. Now, quick secret, whenever I get a new insect, whenever I figure out something new, what I do is I actually have this is all my casework, I have a developmental data sheet. So what this is this is all the developmental data. You see all these different signs, pages down here. These are all the different species. So that way I have the developmental data already in here, ready to go. So I can just copy and paste this in a spreadsheet and do my calculations on that spreadsheet. So it's easier than trying to look up papers and trying to look up the data all the time. I've already looked up those papers. I already put them in there. But I will always do the calculations here because I'm going to give this to the police officers. I'm going to give it to the detective, to the lawyer. I want them to know exactly what I did because I want them to be able to replicate it. All right. So that's how you do what you're going to do. Let me know if you have any questions.